Right. In the previous lesson, we talked about a quadratic function, whereby we know that a quadratic function can be denoted in three different ways or have three different ways in which it can be represented. We talked about the first one, which is a x squared plus bx plus c. So in this session, I want us to check this formula here, and then let's talk about this equation here and the symbols involved in it. All right, so the good thing about this equation, if you are given an equation in this form, you just know that the value of a, we know that it determines the shape of the graph. So if a is positive, it means we have a smiley parabola. If a is negative, we have a sad parabola. Okay, then now let's check the effect of p and q. So the value of p and q gives you the coordinates of the turning point of your parabola. So it means the value of p gives you the x coordinate of the turning point, and then the q gives you the corresponding y coordinate of the turning point. So in order for you to determine the turning point given this equation like this, it means your turning point coordinate is going to be the value of p, which correspond with the value of q. Suppose you are given y is equals to minus 2 into x minus 1 all squared plus 4. So if you are given an equation in this format, and then you are supposed to determine the coordinates of the turning point. In this case, to get the value of p, the exact value of p, you are going to take whatever is in the bracket and then equate it to 0 and solve for the exact x turning point. So in this case, we are going to have x minus 1, which is equals to 0. Then our x value or our x turning point value is positive 1. So to determine your turning point, we're going to say TP. And then your x turning point, we know that it's 1. And then the value of Q together with its sign, we take them the way they are. If it was negative, we're going to take that negative there. So it means in this case, it's positive 4. So here you have it. These are the coordinates of your turning point of this function. So similarly, if you're given maybe an expression like this, and then to determine the coordinates of your turning point, it means we take whatever is inside, we solve for x, then we're having x plus 5 is equals to 0, and then your x value becomes negative 5. So your turning point in this case, it means we are having negative 5 is 2, and then we take q together with its sign, then it means it's negative 6. So this is the effect of p and q for now. But we also know that the value of p and q can also play a role in vertical and horizontal shifting in that manner. All right. So without wasting time, let's check an example on how we can apply this formula. All right. In most cases, if you are given the graph and it requires you to find the equation of the graph of that parabola, you are given a graph with some points there, and then you are required to find the equation of the graph. In most cases, for you to apply this formula here, you'll be given a graph whereby on the graph you are given the turning point coordinates. If you are given the turning point coordinates and at least one point on that graph, then you can determine the equation of the parabola or of that parabola given this condition here. So if you see the turning point on a parabola and at least one point, and then now you can use this formula here to find your equation of the graph. And in most cases, they will say to you find the equation of the graph in the form y is equals to ax squared plus bx plus c. Now, if we can check this second equation here, is just the first equation. It's just that they have completed a square. So it means that the two equations are the same, but in different form. So let's look at an example so that we can see the application of this formula here. How to determine the equation of the graph. Here is our example. We are given S, whereby the coordinate of S is 1 and 18, which is the turning point of a graph of f of x given by that function ax squared plus bx plus c. And then you're given point P and T, which are the x-intercept of the function f. So the graph of g of x, which is a straight line graph, as you can see, the equation of the straight line graph is given by negative 2x plus 8, has an x-intercept at t, right at that point there. Then R is a point of intersection of what? Of F and G. So it means R is a point of contact between the two graphs. So this is the graph. You are given a parabola which is having a turning point, and then you are also given the equations of the two graphs. The equation of f of x, we know that this is ax squared plus bx plus c, and you're also given the graph of g of x, which is equals to negative 2x minus or plus 8 plus 8. So this is what we are given. So the first question says calculate the coordinates of t. So they said to us t, okay, the graph of g of x given by this equation has an x-intercept of t. So they want the coordinates of t, which is the x-intercept of this graph of g. So when we calculate the x-intercept, okay, for the x-intercept, we let y be equals to 0. Okay, so it means we're going to have 0 is equals to negative 2x plus 8. Then we take this 8 to the other side, it's negative 8, which is equals to negative 2x. Divide both sides by negative 2. Divide both sides by negative 2. Okay, then it means now our x value becomes 4. So it means the value of x here at t is 4. And then we know that the corresponding y value will be 0. So the coordinates of t, it's 4 is to 0. Then the second question says, determine the equation of f in the form f of x is equals to ax squared plus bx plus c. Then they say show all your workings. So in this case, if you observe, we are given the graph of f of x and g of x. So from the graph of f of x, because we want the formula for it, you can see that we are only given the turning point and at least 1 point on this graph. And that 1 point there is point t, because point t also lies on graph of f of x. So if you're given the turning point, our turning point in this case, we know that this is point S, which is 1 is to 18, point S, which is 1 is to 18. And then we also given a point which is point T, 4 is to 0. Then they want you to determine the equation of the graph with this little information. Then that is where you're going to apply the formula, which says f of x is equals to a into x minus p all squared plus q. This formula will help you to determine the equation of the graph. Then we are going to substitute the turning point because we know that P and Q are the values of the turning point. Then it means in this case, we're going to have y is equals to a into x. And then remember, this is positive 1 here. When it comes in the bracket, it will be negative 1. Then all squared plus 18. Then in this case, we can substitute the value of t, which is 4, is to 0. Okay, where we see x, we're going to put 4. And then where we see 0, we're going to put 0. The aim is to solve for a. Then it means we're going to say 0 is equals to a into, then the value of x, we substitute 4, then this is minus 1 all squared plus 18. Then we're going to have 0 is equals to, then inside here we're going to have 3, and then we square 3, it's going to give us 9. Then 9 multiplied by a plus 18. Then we can take this 18 to the other side. Then we're going to have negative 18 is equals to 9a. Then we can divide both sides by 9. Then our a value becomes negative 2. Our a value is negative 2. So remember, when we said a determines the shape of the graph, when a is less than 0, then we have a set graph. And we can see here the type of or the shape of the graph. This is a set, this is a set graph. Okay, so after you have found the value of a, after you find the value of a, it means you go back here and substitute the value of a. So it means now our equation is y is equals to, then the value of a is negative 2, then this is x minus 1 all squared plus 18. Remember, they wanted the formula in the form, in this form. Okay, so we just have to multiply everything out here. So it means we're having y is equals to negative 2. Then we can work this squared out. Then it will be x squared minus 2x plus 1 plus 18 there. Then when we multiply, we're going to have negative 2x plus 4x minus 2 plus 18. Then we can add the like terms. We're going to have negative 2x squared plus 4x. Then this one will give you positive 16. So this is your f of x. So this is the equation of this function. Okay, this is how we find the equation. So the third question says, if f of x is equals to negative 2x squared plus 4x plus 16, then calculate the coordinates of what? Of R, whereby we can see that R is a point of contact between the two graphs. So if they want the value of R, it means we must take the graph of f of x and equate it to the graph of g of x. And then we can solve for x. So before we solve for x, you see this equation is the same equation that we got here. So it means our equation that we calculated, it's very much correct. So let's go to number 3. They want the coordinates of R. Okay, they want the coordinates of R, which is the point of contact between the two graphs. Then that is where we're going to say f of x is equals to g of x. Then this is negative 2x squared plus 4x plus 16, which must be equals to the graph of g of x. The equation was given by negative 2x plus 8. So this is equal to negative 2x plus 8. Then we take the rest of these things to the other side. Then we're going to have negative 2x squared. Okay, when we take this 2 to the other side, it becomes positive 2x. Then it adds with this one, it becomes 6x. And then when we take this to the other side, it becomes negative. Then 16 minus 8, it's positive 8, which is equals to 0. Then I can divide all these things by negative 2, negative 2, negative 2. Then I'm left with x squared minus 3x minus 4, which is equals to 0. Then I can solve for x here. X minus 4, x plus 1, which is equals to 0. So our x value can be 4, or our x value can be negative 1. Then we found two x values here. Then we go and check this point of r. We can see that these are the negative, this is the side of the negative x-axis. So it means we got x is equals to 4 and x is equals to negative 1. So it means x is equals to 4 is out. So x must never be equals to 4 at this point. So it means we're going to take this one. So our x value here, it's negative 1. Okay, so to obtain the y value there, we're just going to take 1. So it means this is like this. X minus 4 is no longer in use. So to obtain the y value of that point, we're going to substitute this point on either on the f of x or on the g of x. So I'm going to say g of negative 1 is equals to negative 2 into negative 1 plus 8. Then it will give me 2 plus 8. Then this is positive 10. So it means the value or the coordinates of r is negative 1 is to positive 10. So this is how we calculate it, and I hope it makes sense for you and it's not complicated, and you can also